Hi everyone, welcome to STEMzebra. My name is Tejas Rakshay. Today we're going to talk about vectors and trigonometry. This is going to be a no math introduction to these topics. If you have not visited our website, please do so. It's www.stemzebra.org. There is a tab there called High School Physics. So if you go there, you'll find links to all these videos. I have organized them, and as I add more videos, I'll organize those as well. Any other teaching material, I'll add it there on the website as well. And today, to help me, is my daughter. She's sitting right there. She's standing there, and she's there because I realized that just staring at a camera is kind of not all that fun. It feels a little bit weird. So I'm going to be talking to her and maybe try to teach her as well a little bit. Okay, so today's topic, like I said before, it's vectors and trigonometry. Those are really useful for physics. So if you either never learned them or maybe you learned them in the past but don't quite remember it, this is a good overview. It's a no math introduction, so we're just going to talk about why it's useful, what is it, how could you use it, etc. So let's jump right into it. What are vectors and what is trigonometry? So let's start with vectors. To understand vectors, you have to first understand another term called scalar. So we have two terms, a scalar and a vector, and I'll write them down just so that you can see it and remember it. A scalar and a vector. A scalar is just a number, one number, and I could just stop there because that is all to it. Right? There's nothing else. And you might say, oh, really? That's it? Yeah, that's it. Usually you use numbers to represent quantities, such as, say, you drove 30 miles. So 30 miles is just a number, one number. So it becomes a scalar. Let's say a plane is flying at 550 miles an hour. So 550 with the unit miles an hour, it becomes a scalar. You bought, let's say, 6 oranges, so 6 is a scalar. So all these numbers where the relevant information is all within one number, that's called a scalar. So then what's a vector? Sometimes just talking about one number is not enough. So you need to give a little bit more information than one number. Let's say that you have a treasure map, a pirate treasure map, and you are in the middle of an island and there's a mark there and it tells you where to find the treasure. So I'll draw a little island and there's north, south, west, east, and you are here in the island, in the middle of the island, and your map, your treasure map says, it has instructions and it says walk 100 steps and there you'll find the treasure. You'll realize that that's not very useful because you don't know which direction to walk in, right? You start from this spot, but which direction do you walk in? You don't know. So just saying 100 steps is not enough. Now 100 steps is a scalar, but you need a direction to go with it. So what if it says walk 100 steps in the northeast? So let's draw an arrow there towards northeast. So you walk 100 steps towards northeast and there you find the treasure. Now that is useful information. So a vector is a number associated with a direction. So vector quantities always have a direction. You can think of a lot of other examples like this that have directions. For example, if you say that you could say a plane is flying at 550 miles an hour, but you should also say which direction is flying in. Otherwise, it becomes kind of an incomplete piece of information. How about this for an example? Let's say that you are trying to model a new building structure that can withstand a hurricane force of some kind. So you've made a computer model of your building design, and now you want to find out whether it can really withstand those forces or not. So to model those winds that are hitting the building and how the building is going to react to it, you have to model all those forces. And those forces are not just numbers, they have directions, right? Some forces are hitting this way, down to up to down, north to west, east to west, whatever. So there are forces in all directions. Moreover, the building itself, there are structures within the building, and different structures are experiencing different forces. And all those forces have directions. So to model it, to simulate it using a computer, you have to model all the forces as vectors. Simply scalar is not enough. So that's one example of how a vector could be used. How about something like Google Maps? So if you're using a Google Map and you're traveling, the map is not just tracking how much you're moving. It's also tracking which direction you're moving in, right? And that's a critical piece of information for a map, because you want to know where you're going on the map. So all those become vectors because they have a magnitude, right? You moved by a certain distance and which direction you moved. Similarly, like a velocity of a rocket or something like that, it has a direction. It has a magnitude, a number. It also has a direction to it. I'll give you another example. If you watch animated movies, let's say the old movies, if you could think about movies from 1960s or 70s, they used to be very flat, right? They were almost like paintings moving or pictures moving. But today's most of them, modern animation movies are not like that. Take Frozen 2, for example. It looks very realistic. It's not just three-dimensional, but it's realistic. Why is it? Because in today's animation, they model different light rays in different ways. So there's an object there. It's not like a painting, right? It's a three-dimensional object, and the object is lit by light. It's reflecting light. It's scattering some light. The surface of the object has almost like different layers, like microscopic layers, and it's scattering lights in different ways. If you model all of that, but think about water, right? Water is reflecting or scattering light at many different depths, not just the surface of water. So just painting water blue is not enough. So when you model all those rays of light, billions in each frame that are reaching this camera where the camera should be, you can get a much more realistic picture of how a scene is going to look like. And that's why today's animation looks a lot more realistic. Actually, if you want to Google ray tracing, please do so. You'll find a lot of interesting information. And all those techniques are dependent on vector definition, right? You want to say, what is the intensity of the light? That's the number. And what is the direction of that light? So the vectors are really common in physics. That's why it really helps to review those vectors and understand how to work with them before you start learning an advanced physics course in high school. Okay, so now let's take the next step. We talked about vectors, but what do you do with vectors? You need to learn to add them, subtract them, multiply them, and multiplying things with direction becomes a tricky affair, right? So we're going to learn all of those things, and that'll give you a really powerful tool for dealing with things with physics, because in physics we talked about forces and velocity and speeds, right? So all those things have different directions and they all interact with each other in physics. So learning vectors gives you that powerful tool. Okay, now it's past 9 minutes, so I'll be quick. Let's talk about trigonometry. Sometimes people just call it trig for short. Trigonometry is about triangles and angles. It's more about angles and how angles behave. It gives you another mathematical tool to deal with angles. But why are angles useful to us, especially in this discussion? Because we talked about vectors, and vectors have directions, right? Different vectors have directions. And to understand how those vectors interact with each other, how to add them, subtract them, or multiply them, you can use trigonometry tools, because those vector directions have angles between them. So to deal with those angles, you can use trigonometry. So we will talk more about trigonometry in our follow-up theory and practice. We'll practice some basic trigonometry problems. Reviewing these will prepare you for that advanced physics that you're going to take in high school. Thank you for watching. That's all for now. We'll talk next time.